So here this what we're going to focus on in this section in the Lippman book, and big ideas about how exponential functions behave and what do they look like, and coming up with an equation and knowing how all the parts go together. So I won't read you those. You can read those. It's also right out of the book, right out of this section 4.2. I didn't give you this page because this is right out of the book, but what you want to look at is we're taking 2 and raising it to the -3. And what you have to remember back from algebra is, and earlier this year, negative exponents mean you take the reciprocals or kick it downstairs. Or as I like to say, I don't know why I wrote -3/8 here. 2 to the -3. So I can think of this as 2 to the -1 cubed, right? Remember you multiply the exponents? So that's 1 over 2 to the 3rd power, which is 1/2 times 1/2 times 1/2, and that's where they got the 1/8 from. And same thing, 2 to the -2 becomes 1 over 4, and so on and so forth, and then we go exponential. So what you want to notice here, this starts very small, then gets very big. When I have the base is a fraction, unless it's less than 1, and we raise that to a power, so what happens there is 2 to the -3, I'm sorry, 1/2 raised to the -3 means you can take the reciprocal, which becomes 2 over 1, and then you're going to cube it, and that's where they're getting the 8 from, and then 2 squared is 4, and 2 to the 1 is 2, and so this starts big and goes down. So exponential decay, this is the exponential decay, and this is also an this is an exponential growth equation, sorry. Base is smaller than 1. The base is bigger than 1. So that's growth, and that's going to be a decay model. Now the other thing that will happen often, if you look down here, I didn't capture it, when the exponent is negative. So when the exponent is negative and the base is a number bigger than 1, that's a decay model too, because you can flip it. 2 to the -x is the same as 1 over 2 to the positive x, right? So if the exponent is negative, generally the base is a large number, I mean a number bigger than 1, so it's going to be a decay model still. So more about that later. So we have to graph this, and some things I'm seeing is, I'm seeing that I've got a decay model, that I just said that number's less than 1/3, so this is going to start big. So let's see here. So this is going to start big and get very small because it's exponential decay. And we can plot some points for it, plot some numbers. In fact, why don't I just a little bit here? So x and y, and if x is, let's see, if x is -1, say, and x is 0, and x is +1, and x is 2. So 4 times 1/3 to the -1. Well, the -1 tells me you got to take the reciprocal of the 1/3, make it 3, flip it, and that'll be 12. 4 times 1/3 to the 0. Well, we know that anything to the 0 power is going to be 1, so 4 times 1 is 4. And then 4 times 1/3 raised to the 1, well, that's 4 over 3, which is 1 1/3, or 1.333. And then same thing, 4 times 1/3 raised to the 2nd. Well, 1/3 to the 2nd is 1/9. 4 times 1/9 is the same as 4 over 9. And I don't know if you've learned this, but that's going to be 0.4444. So getting smaller and smaller as we go. And so my general graph is right, starting big and shrink and going off. Now, what's some crucial things? Now, it's never going to cross the x-axis. It's always going to be a positive number as long as it's just a basic function not being reflected. The other thing that's happening is when x equals 0, y is 4. So that's the y-intercept. See, that crosses right there at 0, 4. And that will always be the case as long as you don't have a vertical or a left-right shift going on. So usually that number, it will be the y-intercept for these basic format functions. So that's one easy thing to remember. So something you're going to do on open math, and there's a couple of problems out of the book like this, is match up what function is which. So some things I'm noticing that these all are exponential growth functions, these other ones are all exponential decay functions, just looking at the graph, right? And so if you have to do some matching up, just remember fractional base will be decay, a bigger base will be growth, and the bigger the base, so like notice how 3 to the x is growing a lot faster than 2 to the x, because this is every time for every x, that's getting multiplied by 3. So 3 to the first, then 3 to the second, and 3 to the third. So those are getting much bigger than, say, 2 or 2 to the second or 2 to the third. Whoops, 2. So that's 8, and that's going to be 27. So the 3 to the x is growing faster than 2 to the x, which is growing faster than the 1.15 to the x. Notice this has a decimal. Even though it's got a decimal, it's not a decay equation. It's a growth equation because 1.5 is bigger than 1. And the same deal over here. The smaller the fraction, I know I just said fraction, but that's 9 over 10, right? The steeper it's going to decay. If you think back to stuff that you did earlier where the base equals 1 plus the rate, well, if we know 1/3 equals 1 plus the rate, well, isn't 1/3 minus 1, which is 3/3? Isn't that negative 2/3? So that means I'm losing 2/3, where it's decreasing by a rate of 2/3 of what it previously was. So this is shrinking a lot faster. The 1 over 3 is shrinking a lot faster than the 1 over 2, which is faster than the 1 over, or 9 over 10. Okay? So now we're going to start writing some transformed functions. And first thing you want to write when you're writing these is to write down this general form. Because what we're going to do is we're going to solve for a number C, we're going to solve for a number A, and solve for a number B unless they tell us. They might tell us what the base is. Then it's an even easier question. So here they're telling us the base is E. We're taking E to the X and we're doing some other stuff with it. Well, I mean, just to talk about transformations and slides and stretches, we're stretched vertically by a factor of 2. Well, remember how that's the number in front of the function? So we're going to write 2 times E to the X. So that's easy enough. And then flipped across the y-axis. Well, remember how on the midterm and the other stuff we did, if we made the inside negative, that flipped it across the y-axis. So what we're going to do is we're going to just make that x negative. That's the f of x. And then we're shifting this whole graph up 4 units. So that's going to be the plus 4. Okay? So I hope that you remember that from the work we did before. If I was sliding it left, if I was sliding right or left, often we won't do that with exponentials, but we would put it inside up here with the x. Okay. So for this question, I'm seeing an exponential decay function. I also see that exponential decay function has been shifted up 4, and I'm also seeing that the y. Well, normally if this plus 4 were not here, let's back up a little bit. If this were the function, 3 times 1/2 to the x power, what would that look like? Well, I'm seeing this. It would cross the x-axis at 3, or y-axis at 3, and it would decrease something like this, which is a perfectly fine graph. You can plot some points. We don't have to, though. So I know it looks something like that. Just this function. Now, but then this plus 4 is shifting this whole graph up 4. So if I count up 1, 2, 3, 4, and then what I'm going to do is I'm going to put a horizontal dotted line, and this is just for me and you right now. You don't have to do this. The way this graph comes down and kisses, and comes very close to the x-axis, or treats it like a horizontal asymptote, that same thing's going to happen up here, and I'm just realizing I needed to add 3 more lines above because this whole graph is getting shifted up 3 units. So it's going to cross 3 units above that line, y equals 4, and then it's going to come down and hug that line. So that's adding the plus 4 to this. Now, if you think about plugging in points, when x equals 0, isn't that 3 times 1/2 to the 0 plus 4. So 3 plus 4 is 7. And notice, where does this graph cross the y-axis? At y equals 7. So we knew that. So then the only thing we haven't dealt with is this, how this negative reflects everything. So instead of crossing at 0, 7, and see, it's going up 3 spaces, so it's going to get reflected around that line and cross 1, 2, 3 spaces below that right here, and then it's going to come up and kiss that horizontal asymptote again. So let's see, I'm going to graph that just so I know where it's crossing, and it looks something like this. And if you see it's been reflected, and you can graph this on Desmo or on a graphing calculator, you're going to see how that works. So I usually think about what it would look like without the reflections and the shifts, and then go from there. Okay, so now we've got to find the equation given a graph. Well, a couple things I'm noticing. I know normally these exponential functions do all their work around the x-axis, and this one is way up here, 5. So that tells me that graph's been shifted up 5. So if you think back to that general form that we looked at a minute ago, y equals ab to the x plus the vertical shift, I can write y equals a times b to the x plus 5, and that's one of the 3 numbers we need to find. Let's see, some other things I'm seeing. I'm seeing this point 0, 2. That's nice. I'm also seeing this point here, -1, 3. And I could probably find some others, but I think this will do it for me. I think this is enough, and we can check. So back before we had any kind of vertical shift, we were able to say, oh, there's that A number. We can just drop that right in. But this vertical shift messes things up. So what we're going to do is we're going to do some substitution here. I know y equals 2 when x equals 0 plus 5. So then I'm going to subtract 5 from both sides of this equation, get -3. And a times 1, b to the 0 is 1. So a is -3. So that brings me down to y equals -3 times b to some power plus 5. So now I've got to find b, and that's where this other point comes in handy. So I know 3 is y times -3 times b to the -1, because that's x, plus 5. Well, let's solve this for b. So I'm going to subtract 5. That gives me -2. And that gives me -3 times b to the -1. Well, let's see. I can divide by, a couple of things I can do here. What can I do? Let's get rid of that negative exponent. So I'm going to write that as -2 over 1. Because I can write anything over 1, right? Equals b to the first, because negative exponents say to take the reciprocal, kick it downstairs, as you've heard me say. So now I'm just going to do the cross products here. So -2 times b to the first equals -3. Then divide by -2, and b equals +3 over 2. So that's my b number. So then to get the equation, let's see, where am I going to write this? I'm going to write y equals -3 times 3 over 2 to the x power plus 5. And that is the right answer. I tried graphing in Desmo. You can verify that and check. So another graph. I see a growth equation. I see that this graph's been shifted down 1. So I'm going to write y equals ab to the x minus 1. I see that it crosses at 0, 2. I see another point. What's my other point here that I want to use? I'm seeing 1, 5, I said. Yes, I guess I am. So 1, 5 is my other point. So let's find that a number. So y equals 2 when b equals 0. So that means I'm going to add 3 to both sides. So 3 equals a. So then I can say that y equals 3 times b to the x minus 1. Now I'm just going to find that base. I'm going to use that other point. Y is 5, x is 1. So 5 equals 3 times b to the first power minus 1. So I'm going to add 1 to both sides. Gives me 6. I'm going to divide by 3. That gives me b equals 2. That was easy. So y equals 3 times 2 to the x minus 1. And you can check that in Desmo if you wanted. What's nice about this problem is they're already telling us the base. We don't need to worry about it. So let's see. I'm seeing an exponential graph that's been shifted up 1. So f of x equals 2 to the x plus 1. I'm seeing that this graph goes through negative 2, 0. So let's substitute that. See if there's a number in front of the 2. So 0 equals 2a times 2 to the negative 2 plus 1. So I'm going to subtract 1. A equals, well, let's see. I'm hoping that I can just make this jump with you. Whoops, no, that is 1/4. Sorry, not 1/4, not 1/2. Because 2 to the negative 2 means 1 over 2 squared, which is 1/4. So then to solve this for a, I'm going to multiply by 4, or multiply by the reciprocal of 1/4. So I'm getting negative 4 equals a. So I think what I've got is f of x equals negative 4 times 2 to the x plus 1. So let's think about this. So I'm seeing an exponential graph that's been shifted up. We did that. They're telling us 2 to the x, but this graph, if it's 2 to the x, normally it would look something like this, right? But it's been reflected around that line, so that's why it's important that a is negative. So for this part, the second one, I'm seeing, so just so you know where I'm going with this, I'm thinking this is a reflected decay equation. Okay, so that tells me the exponent's going to be negative, or I got to write the 2 as 1/2. Okay, I see it's been shifted up 3, so I'm going to write y equals 2 to the x plus 3. And then I'm seeing it crosses through 0, 1. So let's see if there's an a number in front of this. So 1 equals a times 2 to the 0 plus 3. Well, I'm going to subtract 3. Subtract 3 gives me negative 2. And 2 to the 0 is 1. So a is negative 3. So I think I've got y equals negative 3 times 2 to the x plus 1. Now the problem with what that is right now, that would be an exponential growth equation that's been shifted up 1, reflected around that line. But growth equations look like this, so if it's getting reflected, it would look something like this. Now it's a very lousy exponential graph. But that's not what's there. So this has also been reflected around the y-axis. So I'm going to put a little negative right there, and that should take care of it, because this is probably 1/2 to a power, and that'll take care of that problem. Now that you guys are getting experts, let's do some quick stuff here. I'm seeing it's up 7, right? So y equals a times b to the x plus 7. I'm seeing that it crosses at 0, 5. So 5 equals a times b to the 0 plus 7. Subtract 7, I get negative 2 equals a. So then I can think, well, let's see. Negative 2 times b to the x plus 7. I need to find the b. So we're going to find some other point here. And the one I used when I did these earlier was, let's see here. Let me find it. I hope I'm not making this too long a video. Let's see. I see that it went through 1, 1. So that's going to be the other point I'm going to use to find the b number. So the base. So 1 is y equals negative 2 times b to the 1 plus 7. So I'm going to subtract 7. I get negative 6 equals negative 2 times b. So then I'm going to divide by negative 2, divide by negative 2. That tells me b equals 3. So I think the equation is y equals negative 2 times 3 to the x plus 7. And I could be convinced that that's true because that looks like a reflected exponential growth equation. Okay. This last equation, I'm seeing an exponential decay equation that's been shifted down 4 units. So that's what I'm going to start with. Y equals a times b to the x minus 4. I see that it crosses the y-axis at 0, negative 2. So let's see if we can find a for that one. So negative 2 equals a times b to the 0 minus 4. So that's going to add 2, add 4, that gives me 2 equals a. And then let's see, there's got to be another point we're going to use. How about 1, negative 3? How about that's a nice, neat point to use? So negative 3 equals 2 times b to the 1 minus 4. So I'm going to add 4, that gives me 1. Divide by 2, I get b equals 1/2. So I'm pretty sure that this graph is y equals 2 times 1/2 to the x power minus 4. And that confirms my idea that this was an exponential decay equation just shifted down 4. So I hope that helps. We'll do some practice in class.